Hey guys, it's Miss Simon. So I wanted to make this video today to help you guys out with science. So remember, yesterday we started talking about our non-contact forces, specifically the non-contact force of magnetism. So today we're going to take a look at another type of non-contact force. And remember, we have two other non-contact forces besides magnetism. We have gravity and we have electric. Okay, so today we're going to be talking about electric or electrical force, right? An electrical force is also non-contact because remember, if something's a non-contact force, something doesn't have to touch it in order for a force to occur. So let me share my screen here. And remember, if I write it down, highlight it, make sure you put it down in your notes. All right, so today we're going to be talking about another invisible force. Again, another non-contact force. So think about this. Have you ever taken off your jacket and your hair is standing up? Okay, I'm sure you have before taken off your jacket, your hair standing up. Well, why does that happen? Or did you ever get to school and notice you have your pet's hair stuck to your clothing? Or going down a slide and you notice that your hair is standing up. So why does that happen? Well, all of those things happen because of something we call electrical force. Okay, so electrical force is the force behind these effects is called an electric force. All objects have a property. Sorry, guys. All objects have a property called a charge, which can be either positive or negative. So go ahead and put this down in our notes, please. Electric force. So all objects have a property called a charge, which can be either positive or negative. So no matter what, all objects have charges. It can either be positive charge or a negative charge. So just like magnets, we talked about how magnets have a north pole and a south pole. The two kinds of charges are called positive and negative. So just like magnets have two poles, north pole and south pole, we also have two kinds of charges, which are called positive and negative. And electric force is how these charges interact with each other, just like magnetic forces, the poles are how they interact with each other. No electric force does not have poles, okay? They have charges, all right? Just like magnets have poles, they don't have charges. Electric force has charges, does not have poles. All right, moving on. So when the same magnetic poles come near each other, what do you think happens? So if we have a positive and a negative and a negative, what do you think happens? Well, I want you guys to think, remember what happened with our magnetic poles. Remember when we had a positive and a negative, they repelled, okay? They pushed away from each other. So what do we think is going to be happening with the electric force interaction? Now I want you guys to think about what if we had a positive and a negative, what do you think would happen? Okay, again, think about those magnetic poles. When we have a north and a south, remember they attract each other, they pull together, okay? So what do you think it's going to be for electric force? What do you think a positive and a negative are going to do? All right, so just like magnetic poles, guys, electric force is the same, okay? Electric charges are the same. Positive and positive, negative and negative, like charges are going to repel. They're going to move away from each other, okay? But unlike charges, different charges are going to attract each other. So a positive and a negative will always attract each other, where a positive and positive are always going to repel and push away, and a negative are always going to repel and push away. So go ahead and put this down in our notes, please. Please draw this chart, electrical force. When there are two of the same types of charges, they repel. So positive and positive, negative and negative, they're going to repel. When there are two different charges, they're going to attract. So positive and negative will always attract. Again, very similar to what we saw with the magnetic poles. Positive and negative, always going to attract. Negative, negative, always repel. Positive, positive, always repel. All right, moving on. Make sure you have that down in your notes. So electric force is actually all around us. Nearly all objects can feel an electric force and move because of it, okay? Most of the time, however, we're not feeling a strong attraction to the wall or the person standing next to you or any objects near you. You don't feel attracted to that, okay? Well, what does that tell us about the charge of things in most cases? Are you going to be completely made of a positive or completely made of a negative? So what does that tell us about the charge? Well, you should probably be thinking along the lines of that. Well, the charge doesn't exist. There's not a charge. And that's what we mean was most objects have as many positive charges as negative charges. So if you add up the same number of charges, positive and negative, you get 0. So we have a neutral charge. So most objects are going to have a 0 charge, which we call a neutral charge. So because the charge is neutral, that's why we're not being attracted or feeling ourselves being pulled to the wall or to other objects that are around us, because we have a neutral charge. So most of us have as many positive as negative charges. So if I add them up, I get 0. And that's called a neutral charge. Go ahead and put that down, please. So most objects have a neutral charge, which means they have a 0 charge. All right, moving on. So which of the following statements about electrical charges is true? Electrical charges can be positive or negative and have north and south poles. All electrical charges are negative. Electric charges are positive or negative, but do not have a north or south pole. All items have an electrical charge that is either north or south. If you said C, you are correct. Remember, electrical charges can be positive or negative, but they do not have north and south poles. Only magnetism, that's the only thing that has north and south poles. Many objects like a chair or a wall or your hair are considered to have a what kind of charge? So what did we just learn? Most objects have a what kind of charge? Positive, negative, or neutral? She said neutral, you are correct. Remember, that's why you don't feel yourself being attracted to the wall or the chair, okay? Which of the following is true about the pair of charges below? Pair 1 will repel and pair 2 will attract. Both pairs will attract. Pair 2 will repel and pair 1 will attract, or both pairs will repel. Make sure we're looking at those charges. Pair 1, they're both negative. Pair 2, they are both positive. So like charges are always going to do what? If you said D, both pairs are going to repel, you are correct. All right, guys, so that was where we are going to stop for today. Okay, so the main points for today to remember are that remember like charges, so positive, positive, negative, negative, they're always going to repel, push away from each other. Unlike charges, positive, negative are always going to attract. And most objects, guys, have neutral charges, okay? So they have a 0 charge. That's why we don't feel ourselves being attracted to the chair or the wall or things like that. So I hope this video was helpful, and I'll see you guys later. Bye.